Very good morning. This is Balaji, Assistant Professor, Department of Mechatronics Engineering, SNS College of Technology. Hope okay. In our last video, we have discussed about some SCADA systems and some DCS systems. So we have discussed about based on the DT, design thinking process. Okay. So in the design thinking process, we have discussed about empathy system, empathy process, and then define process. In empathy, why we need to use the DCS. We need to use the DCS, and then in the defined process, what are the rectifying methods? Empathy and need of thinking methods we have discussed about in our defined systems. Okay, so I'm going to recall all those things. So in empathy, in the traditional methods, people will be having manufacturing cost and cabling cost, and then monitoring, manual monitoring, and then those kind of data storage, so storing, and then those kind of without application manually will be using all, will controlling all those processes. Okay, for rectifying all those problems, we can use the DCS. We can use the DCS. Okay. And then if you are using the DCS, we should have reliability and flexibility and efficiency. Okay, so for the application we can use the DCS. So next. So idea. So we have discussed about our empathy. We have discussed about what are the rectifying methods available in our for our problems. So specifically for our problems, for our need, we can use the DCS for the applications. Okay, which means the distributed control systems. Okay, so in DCS we'll be having four level of control applications are available. One is the field level, direct level, plant supervisory, production control, and then production scheduling. Okay, so we'll be seeing seeing from the down to the our up. Okay, in the plant we'll be having many kind of actuated devices in our down the line. Okay, like sensors and actuators, single acting cylinders, double acting cylinders, DC motors, stepper motors, those kind of field devices available in our field level one. Okay, so those kind of sensors will be checking the parameters like pressures, temperature variable from any kind of actuators. Okay, so and then we'll be having direct control devices, which means microprocessors, and then our PLCs, programming logic controllers, and the remote terminal units, and then process control units, and then many kind of control units. It may be any kind of applications. Okay, it's available in our direct control systems. Okay, so in direct control system, those kind of system will be getting the feedbacks from our field devices. Okay, field devices. So after that, plant supervisory. So plant supervisory, those kind of systems will be controlling the all kind of PLCs which are available between our supervisory computers and then our field devices. Okay. And then production control. So it's it may be coordinating the time dependent process. Okay, and then our production scheduling. Okay, and finally we can see all those controlling process in our single window. So you can see in field devices we can control all kind of data by using these single sensors from our actuators, and then we can fetch the data to our PLCs. Okay, and then PLC will send the data our supervisory computers. Okay, by using the existing data and then user data, it comparing all those kind of data, and then it will give a command to our PLCs. Okay, and then PLC will give a data, will give a command to our sensor will give a command to our field devices. Okay, field devices, and then after that we having say many kind. So that is what we have seen in our all those kind of controlling process. Okay, so I'm repeating again. In our architecture, we'll be having a computer center. This is the base one, and then we having coordinator computer systems, and then we having four kind of supervisory controls. Okay, it may be like our SCADA system. SCADA system is used for to monitor, to control, to store our manufacturing data. Okay, it may be manufacturing part if it's the further manufacturing plant, and then these are the controllers. It's like PLCs, programming logic controllers, remote terminal units, and then local control units. Those kind of control systems are available in between our supervisory computers and then our field devices. Okay. Finally, we having our sensors. It may be any kind of sensor which are depends our application. Sensor will be vary, and then our field devices like motors, lamps, the blotting cylinders, those kind of devices are available in our field devices. Okay, so here data will be communicating by using some kind of communication protocols like ART protocol, which means a highway addressable remote transducer, and then OSI models, and then some other communications. Okay, so if you want to communicate data between high range levels and high distance level, we can use the PROFIBUS, Modbus, and then Fieldbus. Those kind of buses will be, you can use it. Okay, but if you want to control the data in a for short line, for the low level range distance, you can use the OSI, and then Ethernet communications. Okay. Yeah, so in PROFIBUS, Modbus, Fieldbus, basically people are using in the industry. Okay, for the power plant applications, for the oil industry applications, people are using the in communication buses like communication buses like PROFIBUS, Modbus, and Fieldbus. Okay, so next. So in key components of our DCS architecture. Okay, so please pause it.